Titan may be the most compelling target in the solar system for future detailed exploration, but we've known of a few other places which also deserve a second look. In particular, the water worlds. Europa is one of the Galilean moons of Jupiter. It's large enough to have significant radioactive heating from its core, and this heat, seeping into the base of the ocean, creates a sub-zero but almost tepid situation where life could possibly exist. There's a mission concept that NASA's had sitting on the shelf for a couple of decades, with no technologies that could not easily be proven and launched, at a cost, however, of several $billions, to go to the surface of Europa, land with a nuclear plant that would slowly melt through the icy surface, and then release a hydrobot to explore the subsurface ocean for life. To do such a mission, scientists speculate on where the thinnest place in the icy surface of Europa might be. We don't actually know where it is, assigning enormous risk to a mission like this because it might not succeed. But at the moment, Europa is not in the highest priority position of NASA for the next decade, so no mission back there is planned. Cassini delivered a huge surprise several years ago when it detected, viewing on its edge, geysers or particles of ice shooting into deep space from the surface of Enceladus. Enceladus is a small moon, almost beneath consideration in the set of moons that Saturn has that were the object of deep study. It's the size of Rhode Island. Cassini's not only seen these ice geysers shooting into space, but has also been able to swoop through the material during a close flyby and chemically sample them, showing that they contain simple molecules but also salt. Whatever liquid reservoir is leading to these geysers is a salty ocean under the surface of Enceladus, and unknown until this discovery. This was a complete surprise. Nobody suspected that a planetary body this small could essentially have all the ingredients for life: liquid water, carbon-based material, and a local energy source. If Enceladus is habitable, then all bets are off. Dozens of objects in any particular solar system might be habitable. At the moment, our information on the geysers on Enceladus is fairly patchy. Cassini was never designed to follow up this kind of a scientific discovery, so we always want more information than we have. In fact, the mechanism by which these geysers release their energy and shoot these particles into space, where the water instantly turns into ice, is unknown. Thermal imaging of Enceladus shows that it has features called tiger stripes that are 20 or 30 degrees hotter than the surrounding areas. The geysers are correlated with the tiger stripes, but not perfectly. So once again, while tidal heating may be what's leading to the activity of Enceladus and the heating of its liquid material to force it to the surface, we simply don't know at the moment.
Recently, Cassini has found that a tiny moon that orbits around Saturn has jets and plumes of water coming out of it. These particles go out and they form the E-ring. And in flying through the E-ring, one of the instruments on Cassini, the Cosmic Dust Analyzer, can take those particles and get a composition. And as part of that, they see salt.
This is salt, and this is what we found in the ice particles we detected in Saturn's E-ring. And what we think is that the salt comes from an ocean below the surface of the moon Enceladus.
The sodium is a tracer for a subsurface ocean. That's the material of the ice particles, a kind of water, like on Earth.
And that salty ocean tells us something about what might be going on inside of Enceladus to create the jets and plumes that you need. Water, liquid water, in contact with the rocky core to get out the sodium. You could sort of think of maybe the plumes of maybe sort of the breath of Enceladus, coming out and telling us something about its interior.
So what we can say is we have a reservoir of liquid water, and liquid water is one of the preconditions for forming life.
I was surprised and also very excited to find out that, we're getting closer and closer to the conclusion that you have liquid water, possibly a liquid ocean, on a moon that's so tiny, and in a place where we didn't expect to find conditions where you might find life. This tiny moon, just 300 miles across, that might have liquid water and the conditions, the precursors for life. The focus, as Cassini continues in its equinox mission and continues on into the future, will be to have more close flybys of Enceladus, to fly through that plume, fly close to this tiny moon to learn more about the processes going on inside.
Some planetary scientists, my colleagues, are frustrated. Those interested in the outer solar system find compelling places for us to visit, but think too much attention perhaps is being paid to Mars, where a number of missions are planned. Some of this is natural. Mars is 10 or 20 times closer than these outer solar system worlds. The missions are correspondingly cheaper, and they take less time. It's at least a decade to plan and execute an outer solar system mission, but we've clearly found some things that deserve following up. Unfortunately, we may have to wait another decade before having a closer look at these fascinating outer solar system worlds. We've known for several decades that there are water worlds in the outside solar system, especially Europa, a large moon of Jupiter that has an icy crust and almost certainly liquid ocean tens or hundreds of kilometers deep below that icy crust. No mission has ever explored below the surface of Europa. Even more surprising was when Enceladus was discovered by Cassini to be sending jets of water that instantly turned into ice in deep space. The geysers on Enceladus, a tiny world 500 kilometers across, were a complete surprise and indicated that it too has all the ingredients for life: carbon material, a local energy source, and liquid water.